Hey folks, so question 10 on conic sections. P is a point on an ellipse whose directrix and axis are shown. The eccentricity is 3/4. So ECC equals the distance from point to focus divided by point to directrix, and that is given as 3/4. Locate the position of the focus. So they're hinting us what to do first, and draw half of the curve. Construct a tangent to the curve from point Q. Okay, so P is a point on an ellipse whose directrix and axis are shown. P is a point on the curve, so it's probably going to be something like this. Eccentricity 3/4. Now, let's get cracking on this. So the ratio of the point to the focus is 3 units. Point to the directrix 4 units. So let's figure out what 4 units looks like. Let's then figure out what 1 unit looks like. Okay, so if that's 4 units, I want to see what 1 looks like. So I'm going to run off at any angle. I'm going to take 2, 3, 4 divisions. I'll line up my 4th division at the end of the line, which happens to be there at point Q, and I'll mark it. I don't actually have to mark any more, but I just will for the sake of it. I really don't need to. But there's a 3, at 2, and at 1. So as we've seen from the start, point to directrix is 1, 2, 3, 4 units. And point to focus is 3 units. So if we can just take the compass and set it to 1, 2, 3 units. I don't know what the measurements are. I just know it. I divided the line in 4 and I took 3 steps. And I can drop that down, and that's the focal point. Right there. Focal point forward. So using the eccentricity, and when we're given a point, I can take it to the directrix, or vice versa. If I was given the focal point, I could divide it in 3 and take 1 unit and add it on and swing up 4. But anyway, there's my focal. Next thing I'm going to do, I know the eccentricity, so I'll draw the line of eccentricity. Line of eccentricity is, so I just put in my second little ruler, rise over run equals 3/4. I'm going to run along more than 40. I'm going to go up there to 80. So I'm running along by 4 units, so 420 is 80. And I'm going to rise up by 3 units, 320s, 60. And from the point where the directrix meets the axis, I can go ahead and draw line of eccentricity. So there's my rise over run set. So 4 units along, 3 units up. You'll also notice, just as always, with an ellipse, the eccentricity is ECC is less than 1. So the angle of the line is less than 45 degrees. Now, what are we asked? Locate the position of the focus and draw half of the curve. So that will get us well along the way. Vertex is always found by going 45 degrees to the focus and dropping down, and I get my vertex V. And I'll go ahead and just construct half the curve. I'm going to go with the top half here. Now, it didn't specify if they'd like the left half or the top half. I'm going to go with the top half. I'm going to also find my second vertex actually going here. And that's going way up there for me. And I'll have to extend on my line of eccentricity for that. Just about, just still within the page, I'll get my second vertex. I might find the center of the drawing. There's the center contour of the drawing right there. That means I could now find major and minor, but I'm going to just go ahead and construct this curve using my ordinates right here. So I have my lattice rectum, and I'm just, how many points will I put? That's 45 mil, so 15, 30 and 45, and I'll just drop one at this side of the focus as well, so one going up there. And we have center point here. I take all of my points onto the lattice. That happens to line up perfectly with P, so it's already there. I'll take this point on, and I'll take this point on. And finally, up along the lattice, I'm going to take compass and swing them all back down onto the ordinate. I guess forever now. The end of the lattice is a point in the curve, that's a point in the curve. Now, the object is obviously symmetrical about the center axis. So I can take everything across the axis, all the points we've found, and mirror them. Now, there's a mistake in this question, and anyone that looks at the solution will probably realise that. The point Q is far too low. It shouldn't really be in line with point P at all. If I wanted to actually make this question viable, make it something that's worth drawing, because unfortunately with the point Q being where it is, it's going to be so close to a horizontal line, like there's so little in it here that it's not really going to look like a proper question at all. So I'm going to change that question. Before I do, I'm going to just draw in the rest of these points, mirror them across the axis and drop them in. I'm just going through this pretty quickly. It's not a very clean looking drawing, but that's my focal point there. That's my next one here. So I just found that focal point which I just mirrored across here on the lattice rectum. That's my second focal point, F there, and I can go ahead and just sketch in the curve. Now, okay, the point Q, if I just move it up a little bit, I'm going to move it up to here. I'd like to just, there's a few ways of finding this. The junior cert way, I think, is in this case one you might have learned at junior cert. A tangent from a point outside the curve. Open your compass to the near focal and swing. Open your compass to the major and swing from the focal. Hopefully that is just about still in shot there. So just to recap it once more, a tangent from a point outside the curve in this case can be done using a method that a lot of you might have learned at junior cert, where you open your compass to the near focal, whichever one is closest to you, and you swing, and then you open your compass to the major from the far focal and swing, and we use that point to give us, when joined back to the second focal point, it gives us a POC. And there's your tangent. Now, that is a tangent from a point outside the curve. Works absolutely fine. Wouldn't look very good from here. Still can be done though. So this point is kind of viable, but it'll give you a point of contact just here someplace. And if we just move it up along the line someplace, we can use that method just fine. So that is a solution to number 10, with a slight adaptation to the question, which might make it look a little bit more like a correct answer. Thanks very much. Hope it helps.